Hello, in this video I'm going to talk about these two pyramids. We have a regular tetrahedron or triangular based pyramid and also the regular square based pyramid. Regular in the sense that all of the edges are exactly the same length. Now I can see that the square based pyramid is larger than the triangular based pyramid because it takes up more space. But how much more? Well, it turns out that the volume of the square based pyramid is exactly twice that of the triangular base pyramid. Now, I find this really surprising, and this video is all about trying to make sense of this beautiful result. Now, before we dive into the proof, here's two results that we will need along the way. The first one is that if you take any three-dimensional shape, I'll illustrate with this little cube, if you double all the lengths, so if you enlarge its scale factor 2, then you end up with a shape whose volume is not just twice as big, but 8 times as big. So for instance, here we have one little cube. This larger cube is twice as long, but it's also twice as deep and twice as tall. So it's a pretty standard result that if you multiply the lengths by 2, then the volume is multiplied by 2 cubed. So the volume is 8 times as big. We'll need that later. Okay, the second result concerns the pyramids. Let's see what happens if you take two square base pyramids and put them side by side. Have a think about this gap in the middle and what sort of shape we would need to fill it. Well, you can probably see that all of these 6 edges here, including this one along the bottom and this one between the 2 apexes, they're all exactly the same length, which rather wonderfully means that I can just plop the tetrahedron in and it fills the gap absolutely beautifully. Isn't that interesting? Okay, we're ready to tackle the main result. Okay, now we're finally ready to see why the volume of the square base pyramid is exactly twice that of the triangular base pyramid. Here I have a few of each. I have 4 triangular base pyramids, they're the yellow ones, and 6 square base pyramids, they're the red, blue and green ones. Let's start off by arranging 4 of the square base pyramids in a square like that. As we've just seen, the gaps in between are the perfect size and shape to plop some of these triangular base pyramids in to fill the gaps. And we now have a lovely dimple in the middle, which is exactly the right size and shape for this upside down square base pyramid, leaving finally space on the top for one last square base pyramid. We now have an extra large square base pyramid. Let's have a look at it from a different angle. Whoa, look at that. It's an extra large square base pyramid. Same as the original one, but twice as wide, twice as deep, and twice as tall. Now, as we saw earlier, that means that the volume of this thing is just 8 lots of the volume of a single square base pyramid. But thinking of it another way, it's also made up of 1, 2, 3, 4, 5, 6 square base pyramids and the 4 yellow tetrahedra. So a teeny tiny bit of algebra. We move the 6 square base pyramid volumes to this side to get 2 lots of the square base pyramid is worth 4 lots of the tetrahedron. Halving both sides, we finally get that the volume of the square base pyramid is exactly twice that of the triangular base pyramid. I hope you enjoyed that proof.